All right, what's up, everybody? So, welcome to this next video on the topic of grouped frequency distributions. So, in the first video of this series, we talked about this idea of frequency distributions, which is taking our raw data and organizing it into something that simplifies and clarifies the raw data that we're working with. The idea being that we want to be able to display, illustrate, or convey this research, this data that we've collected to our audience in a way that helps them make sense of the data that we've collected. So, what are group frequency distributions? Why are they any different than a regular frequency distribution? So recall that frequency distributions are created to help transform our raw data, as I just mentioned. Grouped frequency distributions will allow us to clarify the presentation of large amounts of primarily interval and ratio data by condensing individual scores into smaller categories or groups. Now, it might sound a little bit abstract at first for me to frame it this way, but consider, if you've ever taken a survey where you're being asked about your age and, the categories that you are being presented with that you can identify your age within are, categories from 18 to 24, 25 to 36, or, 35, 36 to 45, whatever the case may be. So those categories, that 18 to 24, that 25 to 36, those are called class intervals. I'm going to expand a little bit more on what a class interval is, but that, when we've collected that data and then display it in something in some form of a table, that is called a grouped frequency distribution. Sometimes you can have those preset categories already available when you're distributing your surveys, and you're cutting out some labor, if you will, that you would have needed to put in to create group frequencies. But what happens if you send out this survey and you are asking people to include their age themselves, right? They're writing it in, they're typing it in, whatever the case may be, and now you've got 3,000 different surveys that all have a different number represented in this age category. That's the point of these grouped frequency distributions. So let's say I distribute a survey. I think I have 67 people here. So I've collected this survey data across 67 people who were in a behavioral stats course in the past. And these are all the ages of the individuals that I collected. Now, similarly to when I presented the original data on the topic of social media avoidance, we had 30 people and we were able to, maybe identify some important pieces of information that were kind of standing out, particularly in terms of, who had the highest number of days of avoidance, who had the lowest number of days of avoidance. It gets a little bit muddier when we include more people, as you can tell, right? Yes, if we spend some time, really kind of just I can't think of any other way to frame it. If we were just sitting here staring at this data, yeah, we might be able to see something. But if we're trying to present this data in some form of research project that we want people to take something away from, it would not be conducive to being able to engage our audience if we were to just present these numbers. So let's go ahead and figure out what it is that we can do with this to then take this data, this raw data, and transform it into a grouped frequency distribution. So here are some key concepts about group frequency distributions that are really important to understand before we move forward in talking about how it is that we create a group frequency distribution. So the first point to make here is this idea of range. So range offers a measure. Excuse me, I've got something in my eyeball. Hmm. Ugh. Okay, range offers a measure of variability, which is also describing how varied or how different our data is. Range is a term that we are going to come across again when we get into the module, actually, the next module after this, which is on the topic of measures of central tendency and measures of variability. This idea of range is actually considered a very, very crude measure of variability because it's trying to see how different our data is. It can be a little bit skewed, however. We'll expand more on that when we get to that next module. For now, we'll just keep in mind that range is calculated by subtracting the smallest value in our data set from the largest value in our data set. If we were to do this based on the data that I presented to you in the previous slide, the oldest person in our data set was 54 and the youngest person was 16. And if we were to apply this formula of range to this scenario, we would take 54 minus 16. I think we end up with 38. Okay, so if I were to ask what is the range of the data set of ages, you would, subtract 54 minus 16 and you tell me that it was 38. Another important concept to know about for group frequency distributions is this idea of class interval. A class interval is a group of value assigned to a particular class. Now, I mentioned this idea of having a category 18 to 24, 25 to 35, and so on and so forth. That 18 to 24 category, that is called a class interval. That 25 to 30, 35 category, that's called a class interval. So each of these smaller groups that are created in a group frequency distribution are called class intervals. It is possible for us to calculate class intervals. In this class, I'm introducing you to the formula, but I'm not actually asking you to do this. This is in part because the data that we're going to work with, I may show you how to transform your raw data into different groups that you can then create a group frequency distribution for, but I won't be asking you to necessarily create a group frequency distribution on your own for any particular purpose. But it is important to know these concepts. So, class intervals can be calculated, and they are calculated by taking the range that you've calculated for your data and dividing it by the interval size. Now, y'all might be wondering, okay, what's the interval size? We haven't learned about that yet. Good question. So, the interval size is the width of a class interval. 18 to 24, right? If 18 to 24 is a class interval, then the width of the scores that fit within that class interval is called the interval size. So an interval size is, talking about how many scores are being captured in a particular class interval. Just as with the class intervals, it is possible to calculate an interval size. You would do that by taking the range and dividing it by the desired number of class intervals. We're not doing this. I'm not asking you to calculate class intervals, nor am I asking you to calculate interval sizes, but know that it is possible to do so. All right. Class intervals have to be mutually exclusive. This is super, super important. What that means is 18 to 24, right? That's our first class interval. The next one is 25 to 34. The person with the highest age in our first class interval at 24, that person can't also be included in the next category of 25 to 35. So the mutual exclusive component means that there can be no overlap between your class intervals. All right. Where one interval stops is where the next interval begins. They cannot overlap. They have to be mutually exclusive. They also have to be exhaustive. And what that means is that all scores that you have in your data set need to be represented in your group frequency distribution. In a couple slides here, I'm going to show you an example of having transformed that survey data into a group frequency distribution. And I'll reiterate these points about being mutually exclusive and exhaustive. But just keep those ideas in mind, right? No overlap, and all scores have to be contained. So, guidelines for creating a group frequency distribution. I want you to know what it what it entails to be able to do this. I'm not asking you to do it though. Okay. I just don't think that's necessary. Necessary. I don't know why I pronounced it that way. Excuse me. I don't think it's necessary for us to do in this class. Um, excuse me. But I do want you to know what the steps are that you would take in order to do this. In order to create a grouped frequency distribution, you have to follow these four guidelines. So, firstly, that the number of class intervals must make sense for the data set. You don't want too many groupings, and you also don't want too few. Okay. So, for example, if I'm collecting data on people between the ages of 16 and 54, I don't only want two class intervals, right? It may not necessarily make sense for me to have everyone from age, 16 to like 32 in one category and from 33 to 54 in the other category. That in and of itself, just having two categories may not be enough categories for me to be able to determine anything from our data. Remember that the point of these frequency distributions and these group frequency distributions is to help simplify and clarify data. In the clarification process, we can't just have uh, in this particular case two categories, two class intervals. That's not going to make sense for us. But again, we have to have a rationale. The width of each class interval, so that is how many scores are contained within each class interval, should be a relatively simple number. So, as an example, I've given you ideas of 2, 5, or 10. That does make it easier to help you organize your data into uh, equally sizable interval sized class sizes, class intervals. That sentence sounded very confusing. What I'm trying to say is having class intervals with the same class interval sizes is particularly helpful for illustrating those patterns that we're trying to identify. The bottom score in each class interval should be a multiple of the width. So, for example, if you have a width of 5 and your rationale for your research is that a width of 5 makes the most sense, then each of your class intervals, the bottommost number should start with an interval of 5. I'll show you what this means on the next slide after we've grouped our data into a grouped frequency distribution. Finally, all intervals should have the same width. Okay, these are your general guidelines for creating a